procedures, subroutines, and functions. Well, this is going to be the last of our topics involving syntax associated with VBScript, and I think you're going to really like this particular topic because in this topic we're going to talk about componentizing your scripts. We're going to talk about how you can take little pieces of scripts, little scriptlets, if you will, and then move them into their own section of the script so that you can call them from within the script multiple times. And that's the concept of a procedure. What we do is we take these little pieces of code and we break them out into little components, and then it allows us to better reuse them if we like them. Let's say we create a function that allows us to change one number into another number, or allows a subroutine that performs a certain function. Once we start moving all of our subroutines and functions into these object-oriented, for lack of a better word, concept, then if we want to use it somewhere else, then we just grab it right out of one script and drop it into another. And so we're going to talk about what procedures are and what subroutines and functions are and where they become useful. But for the most part, understand that why you would use subroutines and functions is twofold. Number one, if you have to redo the same topic over and over and over again, that's a good way to use it. Or secondly, if you want to be able to take something that you think is really cool and really neat and then use it in other scripts and be able to cut it out very easily and paste it back into other scripts. We're going to talk about how you componentize your code, and then we're going to go through some basic uses and also some more complicated uses about how we would use these subroutines and functions in our scripts. First of all, let's go ahead and talk about what these are. Let's do a quick definition of what a procedure is, what a subroutine is, and what a function is. The official definition of procedure is it is a separated line of code or separated lines of code that is used for a specific task. And this task is for repeatability and also for easy viewability whenever you're viewing your code. There are two different types of procedures inside of VBScript. One is called a subroutine and one is called a function. Now, a subroutine is a specific kind of procedure that typically does not return a value. You use a subroutine when you have an action that you need to accomplish. It can return a value, but it typically does not. Conversely, a function is very similar to a subroutine, but does return a value. You'll use functions in different ways than you will use subroutines. And in a lot of cases, a function involves numerical manipulation, and subroutine may involve some additional activity. And we'll talk about, as we go through the examples in this section, of when you'd use a function and when you'd use a subroutine. So let's get out of this whole concept of what's going on inside of our script, and let's actually go into some of our scripts and see where these are useful. So the very first thing we want to do is talk about some very generic functions. Let's go ahead and open up VBS Edit again, and we're gonna create a very generic function. Let's call this function convert to Celsius. Okay, and so what this function is going to do is at any point in our script, if we have a number that's in Fahrenheit and we want to very quickly convert that number in Fahrenheit into Celsius, we can do that. Obviously, in order to do this, we have to give it a variable or some information that we put into the function. We'll call that int temp for a temperature that's an integer. And then we'll take that information, and then we need to perform some activity on it, some action. And here we'll say, okay, convert to C. So this is our function, convert to C, and what is that? We're going to take the temperature in Fahrenheit and convert that to Celsius. Now, the way we do this is we subtract 32 degrees from the Fahrenheit temperature and we multiply it by 5/9, and then that's how we get Celsius. So let's go ahead and create the math right now. So we go parenthetical, int temp, minus 32, and then we multiply that by 5/9. Okay, so that's the actual conversion to take a Fahrenheit temperature and convert it into Celsius. Obviously, when we get done here, we have to end function. Okay, so we've actually now created a function. This function takes in one piece of information, this int temp, and then puts out another piece of information, which is the converted value once we've run the function. In order for us to actually run the function, we're going to want to wscript it to the screen. So we go wscript.echo, and then instead of actually echoing the variable to the screen, or instead of actually echoing a method to the screen, instead we actually echo the function to the screen. So we say convert to C, and then we have to give it a value. Let's say 95. Okay. So now if we want to actually write to the screen the converted value of 95 degrees Fahrenheit, which is a very hot temperature, then we would say wscript.echo the function name and the value that we're passing into the function. You'll see if we run the script now, we'll see that the resulting value is 35. So we create functions as ways to actually manipulate numbers that we bring in or manipulate data that we bring in, and then we provide that as a result. We then need to do something with the result. In this case, we're echoing to the screen. We could put it into a database. We could inject it into an array. We could do all kinds of fun things with it. What's neat about functions is how malleable they are. If we wanted to, say, do another function instead of convert to Celsius, let's say we want to have support for both functions. And we sort of say, okay, I want the ability to convert to Celsius, but I also want the ability to convert into Fahrenheit. And here's what we've done also. We've created a separate function called convert to Fahrenheit with the same number in there. And we said, okay, convert to Fahrenheit, and then this is the conversion. You take the number, you add 32, and you multiply it times 9/5. And so what you'll see here is we can say, okay, convert to wscript.echo, but instead of convert to C, we can say, okay, we're going to input in convert to Fahrenheit. Now this is going to assume, okay, well, that maybe it's not 95 degrees Celsius. That's pretty hot. Maybe we're going to make it, I don't know, 20 degrees Celsius. If we run the script again, you'll see that now we have 35 and 68. It doesn't really matter that inttemp is called before we actually reference it here inside of our function, but that's the value that we're passing into the function whenever we are initiating and whenever you're instantiating that function. Now again, the first thing you're probably saying when you see this is, well, I could do that. This is a pretty simple math equation that we could do inside of this function. We don't need to create all this extra code to do it. But if we're repeatedly creating numbers, or repeatedly converting numbers from one to the other, or we're repeatedly needing to do this math function, we would want to create a function to separate it out and put it at the bottom of our script. Now think about it. If I put this inttemp minus 32 times 5/9, and instead I put this there, I put it, I don't know, here, right? I'd have to keep typing that again and again if I had to use it throughout my script again and again and again. But by putting it down here inside of a function, I only have to refer to it by the name, convert to C. So by doing this, I actually save myself time. More importantly, though, let's say I create another script at some point in the future. Maybe a year down the road, I have another script that I need to do some temperature conversions again. It is very easy for me to copy and paste this function out of its location and into the new script. And that's a big power of functions and subs, is that now they're very componentized, and I can very much easily add that component information into my future scripts. Now, functions are all fine and well, but I think it's actually subs that are really going to excite you. And the reason why I say that is because subs do more than just data manipulation. With subs, you can actually perform actions on things. If you remember, not too long ago, we created a script where we looked at hard disk information. We enumerated the hard disk information. We brought out the computer name, the device ID, which is, the C drive, the E drive, etc., and how much free disk space is available on that hard drive. And in that example, this is back when we were talking about emailing results. We put some email code on the bottom of the script so we can say, okay, once we've got the answer, let's go ahead and email ourselves the results so we can maybe get that to our pager or somewhere else. Well, when we did that, we created that email information and we put it directly in line with the script, which is fine. There's no problems with doing that. But by creating it in line with the script, sometimes it's difficult for us to try to rip that out if we want to, again, to follow along with this concept of componentization. And so what I want to show you now is not necessarily a function, but is a subroutine, and how we can leverage subroutines to componentize those scripts. What I want to do with this script that we've used before is take the results of this script and then pass it into a subroutine and have the subroutine handle all of the emailing. Let me go ahead and paste some information in now, and I'm going to paste in that subroutine, and we'll take a look at how it actually works. So I'm going to go to my script here, and I'm going to enter down a few times so we can get some space in there. And then I'm going to go down here to my, my other script, where I'm just ripping this right out of another script, and I'm going to paste it in. And the first thing you're going to notice when we paste in this subroutine is how very similar it looks to what we've seen before. So we close the file, we open it up for reading, and then we set this, we create this cdo.message object. We populate the object with a bunch of attributes, and then we go ahead and send the message. The only difference from what we see now and what we saw before was the addition of this line 25 here. This line 25 actually initiates the subroutine. It says, okay, this is a sub. The sub's name is going to be email results, and there are 3 items in email results that are passed into email results. This str from mailer, str to mailer, and str subject mailer. And here at the bottom we do in subs. It's very similar to the indiff that we've done before. And as I said, I just copied and pasted this out of another script because it's componentized. So this is the component of the subroutine. This is the actual stuff that we can pull out of the out of other scripts. We now need to actually call this subroutine in our script as well. And I'm going to go ahead and copy this out of here and paste it in there. So the way we call this subroutine is we say, okay, we're going to say email results. Paste this in here now. Email results. and then 3 items, str from, str2, and str subject. These are the 3 items that I want to pass in to my subroutine called email results. Now, the first thing you're going to say is, wait a minute, str from is not equal to str from mailer, and str2 is not equal to str2 mailer. Those are 2 different words. Am I doing 2 different variables? Well, in a way, you are. Inside of the subroutine, we want to create our own variables that are referenced inside of the subroutine at all. What's important, though, is the order in which I'm passing in the variables. I have to pass in the same number of variables, and I have to pass them in the same order for the subroutine to work. So you'll see here that I'm passing in 1, 2, 3 variables that are involved with from information, to information, and subject information. And in the subroutine, I have 1, 2, 3 variables, and they're all involving from information, to information, and subject information. By doing this, I don't get any silliness associated with the variable names being used outside and inside the subroutine. Again, there's nothing that says I couldn't use the same names, but it's a good practice to always change the names inside of your subroutine so that they stick inside of the subroutine. Now, I have not initiated or instantiated what this str from, to, and subject actually is, so let me go ahead and actually populate from, to, and subject with some more information. Now, let me go ahead and copy this again down from my other script and paste it in right up here, and there we go. So str from now equals Greg at abccorp.com, to is Bob, and str subject is Houston. There's a problem. When I call this subroutine, now email results is going to use this information to push it into the subroutine itself. Now, you're probably saying, okay, well, that's great. I've got the from, to, and subject information, but what I'm really interested in is the free disk space, right? And this allows me, by asking this question, to show you how you can take variables globally inside of your script and have them automatically work inside of the subroutine. It also validates why we want to change the name from here to here. You'll notice down here under text all, we're using this obj output file.readall. It's the same output file here that we're closing and reopening. This obj output file is the same output file up here earlier in the script that we're actually instantiating. Because I personally just tend to use that name always to reference my output file, I refer to it globally down here in the subroutine. Now, it may be a good idea to create another variable called str output file mailer or something like that, and then pass that into the subroutine. I can do that, but I want to do this in this way to show you that it is entirely possible to take variables from the global script and run them inside of the subroutine. So I want to consider when I create these subroutines whether I want to create variables specific to the subroutine or ones that can be passed inside and outside of the subroutine as well. And that's really up to you when you make these decisions. When we run this script now, and I'm not going to run it because I don't have an email server, a SMTP server to run it against. When we run this script, I'm going to get an email to Greg at abccorp.com, or excuse me, Bob at abccorp.com from Greg to say, Houston, there's a problem. And will include the results of our query about hard disk information. Let's go ahead and close this down, and I want to open up VBS Edit again, because I want to do this with a brand new script that we've created. And I'm showing you this as an example of how you would take a piece of code or a scriptlet that you thought was really cool, and how you can translate that into something that's very componentized. So I'm copying this piece of script now from my other script that I've created, and now I'm going to paste it in here. What you'll see is a pretty complicated function in here. And what this function actually does is one that I've written because I had a problem. I would get these long series of numbers. And in these long series of numbers, it's very hard sometimes to understand what the number is because there's no commas separated by those numbers. And so I sat down and I spent, oh goodness, I think I spent like 4 hours one day trying to figure out a way to add commas into an inputted string of numbers. And as you'll see here, and I'm not going to go into great detail associated with the process of doing that because it involves four next loops with steppings of 3. So we're jumping through the loops 1 by 1 or 3 by 3, and we're doing a lot of modulos in here so we can figure out exactly what point we are in the script. It was a fairly complicated script to write, and I wanted to make sure that I captured this script so that I could use it later on, and we'll talk a little bit later about where it's handy. So what this function does is I've taken a bunch of manipulation of data and then just run them in. This is a more complicated example. If before you were saying, well, why would I keep redoing this convert to Fahrenheit, convert to Celsius thing? Well, this is an example of when you might want to use a function that you reuse again and again and again. Let me go ahead and see this number here. You see this very long number? I don't know. What is this? Is it a billion? Is that a trillion? What is that number? However, if I go ahead and run my script now, you'll see that my script very nicely adds the comments in here. So I can see that, well, there's the millions, there's the billions. That's about 1.2 trillion is what that number is right there. If I go up here and I change the number from that to, I don't know, a different number, and I rerun the script again, well, now it's 73,849,325. So back to the concept of functions, and I know we're skipping back and forth between functions and subs, but I want you to see where these are useful. Again, I may have some need to go and add this function information into a script that may already exist. And I don't want to have to retype this all the time or try to have to peel it out of an existing script and keep all the variable names the same. This function is called add commas, and it has inside of the function a number called strnumber. And strnumber, it doesn't matter where it's at, but this is the number that is inputted at the command line. Right here, you'll see this number that we created, and all of this crazy manipulation is done to it. When it's complete, it returns the value of strnumber back to the user. And in here under line 3 is actually what's doing. This is the only part of the script that actually does anything outside of the function. It says, okay, echo to the screen the results of add commas and the number that's identified above. So this is how we actually get this separation of commas, how we do it from within this function. Now let me take this function that we've created and show you where it may come in handy. I'm going to go ahead and close this down, and I'm going to reopen example3.vbs again, which is again that script that pulls free disk space out. And I'm going to do this because by doing this, it's going to pipe to a file with the results of the free disk space. Once that file is complete, you see the script is complete here, I can go to results.txt. And if I open it up, you'll see, okay, VB Nugget, DC Nugget, Nugget 1. Let's see, drive C has some large amount of space, and on Nugget 1 we have some somewhat smaller amount of space. But as you can see here, these numbers are kind of hard to read. And so what would really make it cool is before I actually sent this to my pager with that subroutine that I created, maybe I'd like to actually use a function to convert this number into one that's actually got commas. Now, because I've created this function before, here, it's very easy for me to add this function into my existing script before I pipe the results, and then call that function before I pipe the results and return back the number that I'm looking for. Let me go ahead and do that now. So we're going to copy this information out of here, and then we're going to go into our old example3.vbs. This is, again, that free disk space script that we've got. I'm going to make some space down here and just paste that to the bottom. Again, it doesn't matter where the function is. It just needs to be somewhere in the script. As long as it's available in the script, we can make use of it. So we've pasted this function in here. Now, if you go back up here, we know that this objdisk.freeDiskSpace is the location that's actually creating that large jumble of numbers that's not very useful to us. And we know that that is a variable, that is a value. There is some value that is pushed to our output file because we're referencing it when we write the line here. So instead of directly referencing objdisk.freespace, instead, let's make that a variable inside of a function call. So instead, we say, okay, let's add in the word add commas, and then close it with parentheses. You'll see here, because we've added the function now, our command line completion will show us that we need to add an object to it. That was the part that highlighted there just a second ago. And so now, instead of directly referencing objdisk.freespace, instead we're putting that into another function that gets called, and the result of that function is written to our output file here. Let me go ahead and run this now. And just as you've seen before, our script completes. But now, instead of as it was before with all that jumble of numbers, if we go back to our results.txt, you'll see now that the numbers have a very nice comma spacing involved between them. And so this is a very good use of functions. So we've talked about functions, we've talked about subroutines here today. Again, I think in a lot of cases, subroutines are really going to be the ones that really that you'll appreciate, because in subroutines you have a lot of ability to manipulate things. You can take and send email stuff out, or you can write to other files, or you can create connections. With functions, you're doing a lot of data manipulation. You're adding in commas, you're doing formatting, you're doing structures, you're changing one number to another. But it's any time that you have to reuse something. everything. And what I think you'll find is that as you're going through your code and as you get more mature in your scripting capabilities, you'll find that you're doing things again and again and again. You're constantly doing the same sorts of tasks. And when you see those, that's when you can wrap those into a subroutine or a function and start creating not only your own script library, but also your own function library. So what have we talked about today? We talked about subroutines, functions, what they are, when they're useful, how we can use them to componentize your code, and also some uses in our scripts. I hope this has been informative for you, and I'd like to thank you for viewing.